This is Student Notes 12.5, Dilations. Okay, a dilation is just simply a transformation that changes the size of the figure, but not the shape of the figure. So basically, we're either making it bigger or smaller. Your eyes will dilate bigger or smaller in the pupils. So if you go ahead and look at this triangle and these two moons, these are examples of dilations. The reason that these two are examples of dilations is because there is a proportional change in size. For example, if the first one was 1 and this one was 2, then it doubled in size. Also, it would be the same shape in a different size. Okay, these two examples right here are examples of non-dilations. These are not dilations. The reason this one is not dilation, or actually both of them, is because the shape changes. Even though they're both still triangles, they're not the same kind of triangle. So you can't have shape changes, and they're not proportional. Okay. We're not going to do example 1 right now. We're going to go ahead and look down at figure 1 and figure 2. It's showing you that ABC is changing to A prime, B prime, C prime, the triangle. So actually this triangle is getting larger. This shape right here is the original shape, also known as the old shape. And the primes, A prime, B prime, C prime, would be the new shape. And this one happens to be an example of an enlargement, because the original old triangle is getting larger to the new triangle. Okay, let's look at the second figure. Triangle XYZ is the larger triangle, so this would be the old one. And the one with the primes, triangle X prime, Y prime, Z prime, is the new triangle. So this is an example of a reduction. So when something gets bigger, it's a enlargement, and when it gets smaller, it's a reduction. Okay? We've learned a few of these words already, such as scale factor. Scale factor, you should remember, this is super important, is new over old. Your new shape over your old shape. For example, if the length of XY was 10 and the length of X prime, Y prime was 2, then what would the scale factor be? The new one would be 2 over the old length would be 10, which reduces to 1/5. So the scale factor is 1/5. It's reducing by 1/5 of its original size. So an enlargement just means that your scale factor is also known as K. Your scale factor is going to be greater than 1 if it's going to get bigger. And a reduction means that your scale factor is going to be less than 1, but greater than 0. It has to be positive. So a reduction, like for example, 1/5 is less than 1. It's a fraction, so it would be a reduction. Okay, let's go to the next page. And we're going to go ahead and look at example number 2. This is a hexagon, chevro, C-H-E-V-R-O, was dilated to form the hexagon chevro, C prime, H prime, E prime, V prime, R prime, O prime. Find the center of dilation by using a straight edge and label this point P. Okay, I'm going to show you how to make the center of dilation. You might have noticed it on these other two figures down here. This was the center of dilation, and this was the center of dilation. I'm going to show you how to make these. So what you're going to do, you're going to take a straight line. So you might need a ruler, and you would connect C to C prime and just continue it straight on. You can do the same thing with H to H prime. Continue it straight through. O to O prime. And what you're going to start to notice is they're all going to start crossing at the same point. R to R prime. E to E prime. And V to V prime. V goes through V prime, R goes through R prime, E goes through E prime, O goes through O prime, H goes through H prime, and C goes through C prime. So the one point that they share, this is on the outside, right here. This is your center of dilation. So this is point P. So we've done step A. Okay, example 2B, is this an enlargement or a reduction? Well, your original chevreau that doesn't have primes is the bigger one. So this guy right here is the old, and the one with the primes is the dotted one, so that would be the new one. So actually the old shape is getting smaller, so this would be a reduction. Okay, and the scale factor, remember scale factor is new over old. Well, I only see a few numbers here. There's a 14 up here from C to H, and there is a 6 here from C prime to H prime. And those two sides correspond. So the new side would be the 6, because it's on the new shape. Over the old one would be 14. And 6 over 14, those are both even, so you would reduce to 3 over 7. So the scale factor here would be 3/7. Okay, we're going to save 3, 4, and 5 for class. So go ahead and turn to the next page. Okay, in this picture we have 2 stars. And we have to fill in the blank here. If a dilation of a scale factor K is centered at the origin, you can use the following rule to find the image of each point. If P is at XY, then P prime is now at kx times ky. Now remember, k is your scale factor. So basically you're just taking your point and multiplying it times the scale factor. It's really easy. So let's look at it number 6 and try this. Quadrilateral ABCD was dilated to form quadrilateral A prime, B prime, C prime, D prime, centered at the origin. Is this an enlargement or a reduction? Okay, well, ABCD was the smaller one, then A prime, B prime, C prime, D prime was the larger one, so this was an enlargement. What is the scale factor of dilation? Okay. So what I would do, I would look at the sides of the sides where I do know the lengths. I don't see any numbers on here, but I do know that CD is 2 units tall, and I do know that C prime D prime is 1, 2, 3, 4 units tall. So what this means is that it was originally 2 and it went to 4. So new over old meant that this doubled. So the scale factor is 2. This shape doubled in size. Okay, where's the coordinates of A? Well, the original A was at -1, -1. And coordinates of A prime are at -2, -2. And what did you notice about these coordinates? Well, obviously they doubled. If we took -1 and multiplied it times 2, the scale factor, we would get -2 for our x value. we took our y value, which was -1, and we multiplied it by 2, we would get -2, which is our new y value for a prime. You could do that for any of these points. Let's try, I don't know, D. The original D is at 3, -2. That's a +3. And then D prime, if we doubled it because of the scale factor, doubling 3 would be at 6, doubling -2 would be at -4. Let's see if D prime is at 6, -4. It is. So this works. Okay, we're going to go ahead and not do number 7 right now. We're going to turn to the back and look at question number 8. Okay. Draw the dilation centered at the origin of triangle ABC with a scale factor of 1/2. Okay, since our scale factor is less than 1, that means that we're going to have a reduction. So let's find out where A is. A is at, this is just quadrant 1 here, A is at 2, 4. Okay. B is at 6, 2. And C is at 10, 6. So if it's a scale factor of 1/2, all that means is that our new triangle will be half of where our old triangle is. So we just cut all of our points in half. So 2, 4 cut in half would be 1, 2. 6, 2 cut in half would be 3, 1. And 10, 6 cut in half would be 5, 3. So let's go ahead and plot and reconnect our new triangle. 1, 2 would be A prime. 3, 1 would be B prime, and 5, 3 would be C prime. So this would be a reduction centered at the origin. I'm going to go ahead and connect to show you my new triangle. We're going to go ahead and save example 9 for class, so I will see you guys tomorrow.